Good morning. How's everybody doing? Good? Nice. Don't be afraid to squeeze in closer. We're all friends here. So today I'm going to be talking about fault-driven development and a little bit of background on this before I get into the actual presentation. I decided to put this presentation together because I worked with a lot of developers who were in more of a traditional on-premises development ecosystem, right? Where making sure that the code was working was one thing, but they didn't really understand or want to understand about the infrastructure side of things. Everything was in a data center, everything ran, an operations team took care of it, and that was kind of the end of it. And as they started to transition into more of a cloud-based development model, a lot of these things came up, like, what happens if a data center gets struck by lightning? Like that happens. What happens if a data center floods out? What happens if someone goes in and turns off a web app? These are the types of things that they may not account for in their code, but invariably at some point in time could potentially happen. Another portion of it is around the vast expanse of things you can choose from when developing. And part of the beginning of this talk is really going to delve into some resources that you all can use to look at different things in Azure if you're not familiar with all the components that are out there. There are a couple of really great websites that will walk you through exactly what they are, what they're used for, how to implement them, and things like that. So for our agenda, I'd like to cover a little bit of context. I'd like to establish the difference between a fault and an exception. I'd also like to make sure that we cover what fault-driven development is, my made-up definition. We'll go into some patterns and practices, some cloud best practices. We'll look at proactive, which is fault tolerance, and reactive, which is fault handling or the traditional exception handling model that we've all come to know and love. So thanks to Wikipedia, we can find all kinds of nice things. This is a definition of a fault. Essentially, it is something that happens at a mechanical or system level that causes an outage, right? And it's an abnormal thing. It's not something that would normally happen. So it's more of an unexpected type of event. Now, an exception, on the other hand, can still be unexpected, but it's a result of machine code being run, right? You programmed something happens, goes wrong, it throws an exception saying that it can't do what it needs to do. So what is fault-driven development? Really, it's a methodology for developing solutions that expect and gracefully handle software, platform, and architectural faults. So some things that you can throw in there are things like telemetry, error handling. One thing with error handling to be mindful of too is there's the difference between application level error handling, which would be your normal try-catch blocks and customized exception types and things like that, but also at the platform level. You might also want to be instrumenting if you're running on a virtual machine. You might want to capture some analytics from that particular virtual machine. Or PaaS components, you can also do that through the Azure Activity Log. You can use application insights to instrument your code and stuff like that. Finally, we come across non-functional requirements. How many folks are familiar with the term non-functional requirements? Show of hands. Okay. So non-functional requirements boil down to things like availability, resiliency, scalability, recoverability, often referred to as the dash abilities. These are all the things that the system or platform is expected to be able to handle, along with mitigation steps should something go wrong. Another non-functional requirement that you can look at is the data need of eventual consistency versus immediate consistency. Some business processes may not care if a record is written to the database immediately. Maybe it can wait 5 seconds, or 5 hours, or 5 days. It's really up to the business to decide the criticality of that. Also, what this is not is about blaming others, so put your blame-storming hats away. It's also not about plate tectonics, fault lines, or anything else related to seismic activity. Just wanted to clear that up. It's a lot of text, isn't it? I'm not going to go through all of these right now, but suffice it to say that there are a decent amount of patterns out there that you can leverage to address things with performance or scalability in your code, as well as resiliency. And some common patterns that you might have already seen out there. CQRS, who's familiar with CQRS? Okay, yeah. A lot of folks have been getting into that as a pattern to remediate reads and writes, issues with reads and writes. You can also do things like static content hosting, which will host all of your static files, geographically located at the best point for your users, so as to reduce latency. From a resiliency standpoint, one of the most common patterns is the retry pattern. If you expect or would like to remediate any issues with a request failing, you can set up a retry policy to take care of that and make sure that it continues to retry at either a rapid pace or an exponentially backing off pace, where each request waits a little bit longer to execute. You can also do things with health endpoint monitoring as well. So now I'm going to jump over and I'm going to show you a couple of things that I think are really handy, and hopefully everyone can see this. If not, just let me know. First up is the docs site, so docs.microsoft.com, and this is the architecture center. This gives you all kinds of really good stuff. If you haven't used this site yet, bookmark it and visit it frequently. There are a lot of things that go on here that get updated rather rapidly, and between the architecture guide and the reference architectures, there's some really useful information in here. Next up, who's seen the Azure Interactives site before? Anyone? This is probably one of the coolest things, and I mean, admittedly, I'm a bit of a nerd with this stuff too, so I mean, you can take my opinion as it is, but what this does is it will allow you to walk through and look at Azure 101, so each one of the components that are out there, what they do, how to implement them. It also goes into design patterns, explaining them, giving you visuals on them, and showing you how to implement them. And then finally, it goes into Azure Security as well. So if you ever have questions or you're curious about the security stance of the platform as a whole, you can check that out. So real quick, I'm going to jump into the Azure products list. Now clearly there's a ton of stuff in here, and we're not going to go through each one of these, but for example, if you wanted to look at Service Fabric, it'll give you a little bit of a description. You can go into pricing, you can go into the documentation directly from here. Same thing for any of the database components, any of the components really that are out there. Now we'll jump into the design patterns. This is really helpful, especially if you're not particularly used to looking at things like performance and scalability and availability, dealing with messaging, things like that. What's nice here, let me shrink this down a little bit. Hopefully everyone can still see that. Yes? Good? Right on. So, with performance and scalability, here are the patterns that are most commonly used to help remediate issues. So you can see cache aside, CQRS is in here, using things like priority queue, sharding, throttling. All of these things can help to lend to a better performant and a better experience really with your application. For example, messaging here, you can see that there's compensating consumers. Again, the priority queue, so some of these do overlap depending on the concerns that you're looking for. And things like queue-based load leveling as well. So allowing traffic to come in at a very metered pace so that you don't overload or jam up any of the input lanes that you have for your application. All right, so back to the slides. Let's talk a little bit about proactive fault handling, so fault tolerance. The first thing I like to go into is the discovery phase. So it's really important to discover areas that are prone to errors in your application. More often than not, you probably already know that because you're in the code every day, you're working with it, so you probably have a good idea of areas that may not be as good as others, right? Another area is mission critical functionality. Now, is there a component or a piece of the application that you're working on that if it fails, disaster ensues? So I'll give you an example. So a couple years ago, I was working on a platform, a really large benefits enrollment platform, and we were using MSMQ to handle our commands, our messages coming in, and we had a bunch of web API REST endpoints handling the reporting aspects. We were implementing CQRS for this. One of the things that we didn't account for was MSMQ filling up. So if there was an issue for some reason and messages are flooding into the queue and you don't account for that, you can actually fill up your disk if you have the MSMQ service installed on your C drive and you let it go max and don't set a size limit on how much space MSMQ can take up. And we learned that one the hard way. That was a little difficult because the entire box seized up. We had to get people involved to reboot the machine, and there were some unhappy campers with respect to their enrollment experience. So it's important to understand where those mission critical workflows are and components are, and try to really shore those up as much as you can. Single points of failure, kind of same type of area with respect to what I was just talking about with MSMQ. If you have one single point in your application that every other component talks to, and that's not highly available, if it goes down, the application goes down. That's not good. So the second area is your expectations around what you're going to get yourself into once you're developing for the cloud. You can expect API calls, methods, processes to fail. That's something that you should really come to terms with right now. It's okay. Failure is an option. It's how you actually handle that and remediate that really makes the biggest difference. Service outages, again, data centers getting struck by lightning, flooded out, even just service outages within a particular region. Every now and again, you might see things come up on the Azure status page about, an issue with logic apps in this region or an issue with web apps in this region. Things happen sometimes, and being able to remediate that is really important. And rounding it out, planning. So, who's familiar with the concepts of business continuity and disaster recovery? Very good. Who can tell me the difference between business continuity and disaster recovery? Anyone want to wager? Yes, in the back? So continuity is that constant that says this is making sure that the application can continue to operate. And then DR is disaster recovery, is the plan that you have to actually fail your application over should there be a catastrophic event, right? So again, lightning strike, earthquake, Godzilla, pretty much choose anything that you want there. Having a plan around that and Making sure that you've got a very good geographic distribution for that disaster recovery is very important. If your DR site is 50 miles away and there's a wildfire that takes out the entire area, well, that's not really going to do you too much good now, is it? Making sure that you've got like maybe an East Coast and a West Coast pair, North and South pair, even geographically across the world. Typically, those will help you out a little bit better. So business continuity is interesting because that's really driven by the business. So your business requirements, the functionality that actually exists within the organization that you work for. I've dealt with a lot of folks who will be very good at understanding the technical problem that they're trying to solve, but they may not really understand the business problem that they're trying to solve. And sometimes that's inherent of people's want to solve a technical problem. Sometimes it's also a communications issue, just making sure that everyone's on the same page with what the functionality is supposed to be and the importance of it to the business. Let's move into reactive. So the reactive approach for fault handling, we'll go into the 3 stages here as well. Capturing, so making sure that you're handling your exceptions. Don't just swallow them, let them die off, anything like that. Make sure that there's some sort of action that happens once an exception is caught. Also, make sure that you're gracefully degrading the experience. When you have an application, especially like a web application, for example, and there's not a custom error page or there's not a custom message that comes back, you get the yellow screen of death, right? The really ugly ASP.NET error page, something went wrong, and generally causes a lot of panic for people who don't know what that means. Making sure that operations that you have going on in there have the proper communication channel back to the user is really important. It's okay to say, oops, something went wrong. On the back side of that, there should also be alerts or notifications that go out saying something went wrong so that people can look into it. Speaking of notifications, notify. So a part of notification is making sure that you're notifying on the right things. Who's been in a situation where your organization has set up a notification channel for errors and it gets flooded with every single thing that could potentially go wrong? Anyone had that? Yeah, a lot of noise, right? It's really annoying. And quite frankly, after a while, you just get numb to it. You're not really interested in what's being alerted anymore because everything is coming through that channel. So making sure that those alerts and notifications are really honed to the things that matter. A 404 for an image, not a big deal. A 500 because a process died might be kind of a big deal. So really sitting down and looking at the path for those alerts and notifications and how they're remediated and sent on for final resolution, that's really much more important. Also making sure you have a clear communication channel and a backup channel. It's one thing to set up email alerts that come directly from the portal. Maybe you also want to have an additional channel for SMS messages, so text messages. Maybe you want to use a program like PagerDuty to allow you to put those things together and have a first, second, third line of defense for sending those messages out. Finally, study. Make sure that you go through and look at what happened, especially in the case of a really big event. Something really bad went wrong, customers are mad, machines may or may not have died in the process. Make sure that you're really doing a thorough postmortem on any of those issues. And these are always a little bit dicey because, as with code reviews, people tend to get a bit defensive, right? You don't necessarily want to sit in a room and have someone pick apart everything that you've just done or pick apart the reasons why something has failed. Well, Johnny checked in this and it caused all kinds of issues. Susie checked in an N+1 query and it ended up bottlenecking the database and everything was locked up. Well, that may be the case, but really focus on the why. So there was a query checked in, an N+1 query, that caused this issue. Just remove the names from it. Make it a bit more objective. Also, feedback. Make sure that that feedback is coming back into the team and to the people who need to know. Now, that's not to say that you need to send the entire postmortem to your business analysts and have them send it to the customers. No, you don't need to do that. There are ways to massage that so that it explains the problem but doesn't go into the really technical details on why. One exception to that would be, has anyone ever seen the postmortems from any of the Azure VSTS outages, Azure DevOps outages, I should say? Anyone? One? Go check those out sometime, honestly. Granted, postmortem reading is probably not on your top list of things to do, but they're extremely thorough, and they also really go into detail on the whys and the hows of the problems that they run into, as well as here's what we learned from this, here's what we're going to be doing in the future to actually make sure this doesn't happen again. Okay, enough slides. Let's look at some code. Anyone here familiar with Poly? A couple folks? I know it's made a couple of cameo appearances this week already, so apologies for any duplication that you may or may not have seen. Poly is a .NET library that allows you to write policies that relate to certain types of patterns for resiliency. For example, Poly allows you to write retry policies for your code. It allows you to use the circuit breaker pattern, which says after so many exceptions, I'm going to break the circuit and wait for n number of seconds. And then I'm going to try it again. Sometimes with that circuit breaker pattern, it allows you to cool the system down a little bit, allow things to queue up, and then process things at a more gradual pace. It helps to reduce the burden there. Another pattern that's in there is also a timeout pattern. So if an action is executing and you're like, if this isn't done in 15 seconds, something's wrong. Just cut it, cut and run, log it, send out an alert, do something, but make sure that someone is on the case and figures out what to do next with this. So now, what I'm going to do is I'm going to jump in a stupid simple example, and I do mean really simple. Basically, all I did was I created a new .NET Core Web API project. So the values controller, it returns the array of strings and all that good stuff right out of the box, nothing fancy. I added a NuGet reference to Poly. I also added a NuGet reference to application insights, and we'll see why in a minute. Now, one additional thing that I did that some examples may not go into if I can zoom appropriately, that would be really awesome. There we go. So I moved a lot of the logic for the testing on this into its own class. And the idea behind that is to say that you can have these policies and this code set up in a modular fashion so that it's not bound in a controller, it's not bound in a console app or a desktop app or anything like that. You can extract it out and have it isolated so that it's reusable across any area. And this is applicable to .NET Core, .NET Standard, and the full .NET framework. So let's look at a really simple example here. We're going to say, in the case of any exception, let's just catch everything. They're like Pokemon, you got to catch them all. Go in and say, I want to do a wait and retry, meaning I'm going to retry at a specific interval for each retry that we're going to kick off. Essentially what this will do is say, this is the amount of time as a time span object that this is going to sleep and wait until it kicks off the next retry. The number of retries is actually being passed in here as an argument, and we'll see why in a moment. On retry, this is where you can do additional logging, you can do additional message compilation to send back to the user. I'm just being extraordinarily lazy and just plus equaling the output variable to include a line that shows there's an error, so that way we can actually see how many retries it goes through and prove that it's doing its job. Next, and this is important, setting up your execution of that policy. Within the execution of that policy is where your actual code is going to live. One thing to do that I did not do right away is make sure that you put your try-catch block around your policy definition. I wasted at least an hour and a few knocks of my head against my desk to figure out that it had to actually move up to that point. So if you are going to use this, make sure that you put that try-catch block around the entirety of that policy. So in this particular example, I have some junk URL that I know is going to fail. And all I'm doing is saying, I'm just going to send out a request. I want this to come back, and I want to check what the status code is. Pretty simple. If it's not a 200, if it's not a response that says, okay, this is cool, then I want to throw an exception for that. If it does come back okay, then all is right with the world. Output says website found successfully. On we go. Now the second portion of this is after it's done all of its retry logic, it's going to finally come to the point where it's catching that eventual exception. And at this point, you should be doing something to make sure that you're not just letting that error drop through and do nothing. So what I did was use the application insights library, spin up a telemetry client, and actually track that error that comes out at the end. Finally, we'll send a message back that says, you know, eventually this failed. Here's how many retries it took. Again, this is for illustrative purposes only. You probably really would not put this out into a customer website. So let's take a look. And we're spinning. This will likely be a little bit angry because it's not the API path, so we will change that. Let's get this out of the way. Oh, there we go. Everyone can see that okay? It's the example, so not a big deal. Now, the getter that I set up for this controller passes in an integer for what would presumably be the record number of the item that you're trying to retrieve. Instead, what I did was I wired this up so that the number that you pass in is actually the amount of retries it's going to go through and execute. So let's do 2. This will wait a second. And now this will come back with an unhandled exception and say that no such host is known. So if we look at that up close, you can see that it's coming back and it's throwing an exception because it can't find that domain of whatever that is. So we're going to let that go through. And it's going to still sit there. It's going to trip again. Now it should trip one more time because we set up 2 retries. So it's going to execute once and then retry it twice. There we go. So it failed after 2 retries. What's interesting, though, is that if you hook up Application Insights and you go into failures, you'll start to track all this stuff, even locally, if you're just running it locally. As long as you have internet connectivity, you can still send all of that telemetry right up to the cloud. And you can see here, I hope, that there are a bunch of socket exceptions that are coming through here. So if you're running this code and you're not debugging it and you're not sure of what the issue is, this is a really good way to capture that. If you look at this, specifically it says no such host is known. You click through it. This is actually kind of cool. I like this a lot. When this loads up, it'll give you the entire trace on that exception from multiple angles. So you can go down to the call stack, or you could just show my code. And I'll tell you specifically where that is in the process in the code. Pretty snazzy. You can also go through and do testing timeouts. You can test out circuit breaker stuff, any of that. It's really, really handy to have. It's handy to use, and it's pretty easy to implement. So the key point that I really want to make sure that everyone walks away from this with is, going from a traditional development environment into a cloud-first development environment. It takes a bit of a mind shift. It takes a bit of a paradigm shift to really pick that up. And knowing that there are tools and there are patterns out there that you can implement helps tremendously in easing any concerns you may have, as well as properly remediating things when things go wrong. So just so everyone's aware, there are resources listed out in the deck itself. So if you are able to download the presentation, you'll be able to get all the links for everything. And please make sure you submit your evaluations. They're extremely important. I like to know if I'm doing a good or poor job. So either way, if you could just let me know, that'd be awesome. And if you want to make fun of me on Twitter, there's my Twitter handle. If you'd like to make fun of me on my blog posts, you can make fun of me at Blogger at that address. And with that, I will open it up to any questions that you may have. Yes, sir.
Recommend organizations strive to run something like Chaos Monkey in order to test these patterns that are hopefully implemented?
Absolutely. So the question is, would I recommend that organizations run things like Chaos Monkey to test these patterns out and make sure that they're viable and that the implementation is good? And the answer is yes. There are a couple of different ways you can do that. If you're using Service Fabric, there's a built-in code base that you can download that will simulate taking out different nodes in that cluster and show you, the health of the cluster and whether or not things are behaving the way that they should. Another one, if you're using Kubernetes, is Chaos Cube. That's another good one. And if you want to roll your own, you can certainly do that as well. But putting that together with your testing strategy is definitely something I would recommend. Any other questions? Awesome. Well, thanks for hanging out. Really appreciate it. Again, please remember to submit any evaluations that you have, and thanks for your time.